Okay, let's do some examples for determinant in which we have to know how the elementary row operations change the determinant. Okay, so the question gives us a matrix A, B, C, D, E, F, G, H, I, 3 by 3 matrix, and the determinant of that is 3. Now, there are 3 different determinants which somehow are generated by some elementary row operations from this matrix. We have to try to turn back our matrix into the original form A, B, C, D, E, F, G, H, I using elementary row operations, and then see how the elementary row operations change the determinant, and at the end we use the fact that the determinant of this original matrix is 3 and compute the complete determinant of the given matrix. Okay, let us start with the first one. Well, right away you notice that there is a multiple of 3 in the first row. So to get rid of that multiple 3, I have to divide the whole row 1 by 3, or multiply the row 1 by 1 over 3. Then the properties of, okay, so let me just write first what does the elementary row operation do. This will give us A, B, C in the first row, G, H, I is here, D plus A minus 2G is there, E plus B minus 2H is there, and let me write it a little bit further away here, F plus C minus 2I is there. Okay, how does this change the determinant? If you multiply the determinant by C, the determinant, if you multiply a row of the matrix by C, the determinant will be multiplied by 1 over C. Okay, which this is just a 3. Well, very nice. Now A, B, C, well, D is down there. But let's first get rid of this A here, B, C here. So if I do add or subtract row 1 from row 3, what will stay there will be D. You see A cancels with A, minus 2G, E minus 2H, and F minus 2I. And everything else stays the same. This, we know that doesn't change the determinant, but we had 1 over 1 over 3, which is equal to 3 from before, so we have to carry that over. Very nice. Now, if I do add 2 times of row 2 to row 3, we will get rid of this extra terms here. So this will give us D, E, F, G, H, I was in the second row, and the first row is A, B, C. We are almost here. We need to change. Well, let me just write the determinant. What did happen here? So we added 2 times row 2 to row 3. We know that the determinant doesn't change. We had this constant multiple 3 from before, we have to carry over. Now, to transfer our matrix to the original matrix, we need now to interchange row 2 and row 3. This way we will have D, E, F, G, H, I. The first row stays the same, and we know that the determinant will be multiplied by a negative sign. Well, we had this 3 from before, we have to bring that. Now, very nice. This is the matrix, the original matrix, whose determinant we know is 3. And now you just plug in there. This will give us negative 9. everything symbolic, everything. There are no numbers here. The entries are the general matrix. We have to do the elementary row operations and see how they change the matrix. Okay. As we talked before, this works for the elementary column operations also, and in this part we will specifically need to apply that elementary column operations. Well, to start with, you see there is a multiple of 4 here, so we multiply column 3 by 1 over 4. This will bring us 1 over 1 over 4, which is 4, determinant of BEH. This is nice. CFI, this is the last column, minus A plus B, minus D plus E, minus G plus H. Very nice. Well, you see that a copy of these column 3, is added to column 2. Why don't we cancel that? Meaning that we can subtract column 3 from column 2. This way, we will have minus A plus D minus B. That will cancel. Minus D minus G. This is BEH. Very nice. And while this operation doesn't change anything, and the determinant stays the same. Don't forget that 4 from the previous step, and we have to carry that over. Okay, very nice. Now we need to take out one negative sign, so negative column 2. This will give us CFIADGBEH. Very nice. But when you do that, your determinant will be multiplied by its inverse. And don't forget to bring that 4 down. Now everything's almost there. We need to interchange some columns here. So interchange column 2 and column 1, and this will give us A, D, G, C, F, I, B, E, H. This way, the determinant needs to be multiplied by negative sign, interchanging 2 columns. From before, we have negative 4, so we have to put that one back in. And now we need one more change. Column 2 and column 3. This will bring us, minus minus, this is 4 times. There will be another negative sign because we interchanged two columns, and this will give us A, B, C, D, E, F, G, H, I. This is the matrix we started with. So this is 4 times. We know that the determinant of that matrix is 3. So that will give us negative 12. Okay. So this was column operations. And the last example is combinations of elementary row operations and elementary column operation. And it's a little bit trickier. We have to figure out something for this one. Okay. What shall we do here? To start with, see, the first column is multiple of 2. So if we divide the whole column 1 by half, or in other words, we factor out 2 from column 1. This will give us what? This will give us A, negative 3G, and then from here we get D. Okay. 3I negative F, B minus 3A negative 3H plus 9 G, and this guy here is E minus 3D. And as you notice, the last column has some multiple of this column here, and well, we can get rid of that extra multiples up there by adding 3 times of column 1 to column 3. As you notice, this will be minus 3a plus 3a will be b minus 3h and e. So this will be what we have, negative 3g, 3i, and a minus c, d minus f. Very nice. Now you see that we can factor out. Oh well, what did this operation do for us? This operation doesn't change determinant. What we have that 2 from before, we have to carry over. Very nice. You see that row 2 is multiple of 3. I would say multiple of negative 3. So let's just divide the row 2 by negative 3, or multiply it by 1 over negative 3. Then the result would be that the determinant will be multiplied 1 over 1 over negative 3, which will be negative 3. And then determinant of a minus cb, g minus I, h, e minus f, d. Very nice. And well, now you see that the column 2 also has a negative sign, so we can multiply the whole column 2 by negative sign just to get rid of that extra negative. From before, we have negative 6, and what we do here will introduce a negative factor there. So this will be a g d c I f and b h e. Okay, almost a b c. So first thing now is that interchange these two columns, C2 and C3. From before, we have 6. Now, since interchanging 2 columns, the determinant needs to be multiplied by negative sign. So this will be A, B, C. Then G, H, I, D, E, F. Almost there. We need just interchange now row 2 and row 3. Here, from before, we have negative 6 there, and since we are interchanging row 2 and row 3, the determinant again will be multiplied by negative sign. So this will be A, B, C, E, A, B, C, D, E, F, G, H, I. And well, this is negative 6 times negative 1, positive 6. And this is the determinant that we are given, and this is equal to 3. So the whole determinant is going to be equal to 18. So you have to be able to see what kind of operations you need to turn back the given matrices into the original form, and then track all the steps, how these steps change the determinant.